Hi everyone, I'm Daniel Calabro. I am, the founder of Ferris. It's a very new role for me because just like all of you, I'm a civil engineer. I was at Rensselaer when I got my degree, came down here to Florida. I was doing structural engineering, high-rise architectural design projects. I had the chance to go up to Cape Canaveral, work with Bechtel, NASA on the Mobile Launcher 2 project. And when I was in college, I started programming. And in 2020, I had sort of this GPT moment where I was going to take ChatGPT and I was going to use it like my design partner. I was going to give it all my drawings, my specifications, my calculations, and it was going to work with me as this design partner. But unfortunately, it lies, and it lies a lot. And when it lies, you can't trust it, and when you can't trust it, you can't use it. So I asked the question, why? And throughout that process is about a 4-year rabbit hole figuring out why it was lying to me and what it was really doing. How are these things constructed? What is a large language model? So I went down that sort of a rabbit hole and I built a little program for myself and I thought it was really cool. Ended up giving it to a bunch of civil engineers in my network and they seemed to really love it. So I started a company. Now it's called Ferris. And today, what I'd like to talk about is just practicing civil engineering in the AI era. I want to start really broad and just talk about what AI even is. Can we define that? Can we understand that? And then work that funnel down to how it's applicable to us in civil engineering and then a little bit about what we're doing at Ferris. So sounds good? Cool. So what is AI? Whether you know it or not, you're probably using it already. So you could have machine learning, you could have different types of natural language processing algorithms, computer vision, and the new thing, which is generative AI. And examples of these are Google Maps, auto reply in your text messages, or ChatGPT. So how does Google Maps work? We probably all use that to navigate in some way, shape, or form. It's taking these large data sets and it's interpolating, hey, when I want to get from Fort Myers to Naples, what does the traffic pattern look like at the specific time? Giving people that are already using Google Maps, what are their times? Are they stuck in traffic? Is there a traffic jam or an accident? And it's running through this giant algorithm to predict the time from point A to point B. That's a form of artificial intelligence. Your auto replies do something very similar. You send a response to your mother, or your brother, or your sister, and it's a very typical like, hey, good morning, and you type in good, it knows the morning is coming because it's seen it so many times in that data set that it can predict the next word that you're going to talk about. And then ChatGPT and these generative AI models. So by a show of hands, is anyone here? I know a couple people use AI actually professionally, which is awesome. Is anyone using some sort of AI within their daily workflows as civil engineers? ChatGPT, something like that? Awesome. So I don't know, let's see. I guess you're gonna maybe all learn something today. Does anyone know what GPT stands for? Any guesses? No? Okay. So I guess we're gonna learn something. That's great. GPT stands for Generative Pre-trained Transformer. Let's break that down. What does that mean? So generative, meaning that it's going to create something, whether it's text, audio, an image, a document. How does it generate this? It generates this based off the pre-trained data. So that's why this data is so important. It's because that is the basis at which it's generating all of this information off of. And then the transformer part of it is the actual architecture from a software perspective on how this algorithm is running and how these large language models are performing. So any questions? If at any point you have a question, please raise your hand. I'd like to be interactive. I don't want to just be up here ranting and rambling. So one thing I'd like to do when we're really trying to simplify down what a large language model is and how it operates, I like to use an analogy, and it's very simplistic, but I think it gets the point across. So what I like to analogize it to is when you're at a restaurant and you want to order a dish. So what are you doing? You're sitting down and the server comes to you and you give them your dish that you want. And the server goes and takes that back to the kitchen. And that's analogous to when you're in ChatGPT and you ask it a question, you give it a command, it goes back and takes it to the language model. So when your recipe's in the kitchen, it's the same thing as when the transformers and the language models are producing your response. And how are they producing your response? Well, they use this thing called self-propagation. It is a newer technique that came about with ChatGPT in 2018 when they launched their company. And what that does is takes your query or command, it breaks it down into specific segments, and it itemizes each segment, gives it context, and then tries to provide the most accurate response to you as the end user. That's analogous to when you're in a kitchen and they take your recipe, they break it down to ingredients, they break it down to how you're going to cook this thing, what chefs are going to be working on which pieces of your dish. And that process is also called propagation, is another feature that they use, where they're taking each individual bit that you've given it and they're relating it to the full context of what you're working on in order to make it relevant. And this was a game-changing technological advancement that occurred in 2018, because prior to that, it was very good at just predicting single words after one another, but it could not actually, in full context, understand what you were trying to get at and also remember the conversation that you were having. So you now, for people that use ChatGPT or Perplexity or Claude, you could speak to it as you would speak to another person. And that's the sort of light bulb moment that occurred in 2018 and why AI is so prevalent today. So what happens then? Your dish gets put together, give it back to the server, and they return it to you. The person that wants to eat the meal, the person that put in the command to your large language model. And I hope that simple analogy kind of makes it a little bit more tangible to understand. Because that is something that I would like to do here today also is I think AI is very much a black box to many people. And there's kind of like this shadow of doubt and confusion about what's really going on behind the scenes. And I think for us as civil engineers, to use these tools and have trust in them, we kind of need to understand them. And what I'm trying to do today is just hopefully make you understand it a little bit better. So why AI? Why now? Obviously, it's all in the news. It seems to be anything that anyone wants to talk about from a technological perspective. And again, the biggest thing was the advancement of the GPT. That was a groundbreaking moment, and it took a few years for them to really perfect it. But now that it's here and the applications that can be built on top of that are immense, and people are realizing that. And the software side seemed to happen in tangent with the hardware side. So if you know what a GPU is, a graphic processing unit, they're very specialized pieces of hardware that were designed specifically to train these large language models on. And without the GPU, there is no GPT, and they seemed to come together in almost about the same sort of a pattern. And anyone that knows the company NVIDIA, that's why they're worth so much money, is because they created that initial GPU, and they make the best one right now on the market to use for training large language models. Also, why is it important? So time to decision, what does that mean? We live in a technological age where everyone's expecting things to be produced, be responded to faster and faster and faster every day. And I think we see that in our projects where our times to making decisions definitely decreases. I know when I was working with Bechtel, I would be getting RFIs and submittal reviews, and in my previous experience, I would get a few days to answer those, and that window closed to sometimes a few hours to get those submittals and reviews turned around to meet project schedules. A very unique condition, but as I talk to many civil engineers out there, I kind of see that same pattern occurring where everyone wants to be at the forefront of the schedule, and there's a giant push to make that happen. And with tools like artificial intelligence, we're using them to help engineers get to those deadlines and those very tight schedules. And something that I really love and I'm really excited about is it's going to bridge this gap of experience and talent. So what does that mean? When I was working for Bechtel and as an architectural structural engineer, I would look around, and I was kind of young. So I got out of school and I was 22 years old, and I was the youngest guy in the office. And then I was 25 and I was still kind of the youngest guy in the office. And then I was 28 and I was still kind of the youngest guy in the office. And I asked myself, is this something that I'm seeing locally, or is this something that's occurring at a more macro scale? So I put some data that I could find from the US Bureau of Labor and Statistics. And what I was finding was, and I posted it on LinkedIn, you can follow me on LinkedIn after this, but in the year 2031 in the United States, if you extrapolate the trends of engineers coming into the civil engineering workforce and engineers leaving, you'll have about 26 civil engineering job openings with only 10 American civil engineers to fill those roles. So what does that mean? I've seen a lot of companies start outsourcing work to make up for that delta. But sometimes the quality of work you get when you outsource isn't great. You're kind of looking for needle in a haystack sort of issues, and brings a lot of risk on for you as someone that's signing and sealing drawings. And I think that AI is going to be a big help for us trying to make up that delta moving forward here. And as more people start to leave than enter, that experience is leaving the workforce, and there's not enough time to transfer it to the next younger generations. And with AI, I really believe we're going to have a tool where we can take that experience of people that are transitioning out of the workforce and save it on a large language model, and younger generations can come back and recall that information so that it's not lost. I always say data is always the most important thing when talking about artificial intelligence, and people talk about how we're going to create data, how are we going to ingest data. I think the most important data is going to be at your firms from an individual who is retiring next month. I think you should take them to lunch. You should take a pen, paper, buy them lunch, and ask them all the hardest things they've ever solved, all the weirdest problems they've seen in the fields, and you should record as much information from them as you possibly can. You might not use it now, on a large language model. But I promise you in 3, 4, 5 years, that valuable information that you're not going to be able to get from them, you're going to miss that. And I think that we should be doing our best as the younger generation of engineers to try to like extend our hand and get as much information from the senior engineers that are out there right now. So I'm really excited about that, and I think it's going to be very promising. So how is this relevant to civil engineering? I kind of started to get into it a little bit before with the knowledge loss from turnover. So at your firms, people are leaving the firm, and you can't get all the data from them. Sure, that's a big problem. Another problem is, as at least I was seeing it in my experience, you'd have people come on and off of projects very often. And when someone comes on and off of projects, what is that knowledge gap that occurs when you're trying to get yourself orientated, when you're trying to figure out, okay, someone put together these SD drawings and I don't really know how they put them together or why they arrange this in this kind of way. Why do they calculate these? Were these specific members even qualified? Where are those? They're kind of like holes that you're trying to fill the gaps to when you're working on this project and getting up to speed. And I think if you're able to record this information onto a large language model, it's going to bridge that knowledge gap when transitioning on and off of projects. So imagine now you started a new role and you're on a new project and you're trying to figure out what the heck's going on. What do? You try to read the drawings, try to read specifications, you try to ask people in your office that might be tangential to the project, but depending on the size of the firm and who is around, sometimes people don't know. And you're sitting there trying to figure it all out. Now imagine you had a large language model that was there before you, that someone was interacting with, feeding information to, and they understand the project from that baseline memory level. I think that's going to be really important. I think it's a very valuable tool, and I think it's a problem that we have in our industry that we don't realize is a problem because it's been part of the job for so long. And it's hard to calculate what like a return on investment is on these types of things. But I think it's going to be very, very important to have this memory continuum throughout all of our projects as civil engineers. So the next thing that I'd like to talk about is decision fatigue. So as civil engineers, we deal with large amounts of data, and these data sets are very complex. They're very difficult sometimes to get through, whether they're submittal reviews, like, for example, like a weld map report where you're trying to verify all the welds and that they all have the proper inspections. Are there processes and tools that we could use to make these better? And I think artificial intelligence is definitely a way we could access a lot of this data. I know I was talking to a firm here that have a lot of data on their servers, and the analogy that I like to use is the data that's sitting on your servers right now is a liability. You have to pay for the hosting, you have to pay for the storage, you're worried about it getting hacked, and it's kind of just sitting there and you're feeding all this money into it. But are you really getting that money back? And in the past, you kind of did by just trying to navigate through it manually through your file explorer or something to that nature. But with a large language model, what you could do is you can infuse a level of intelligence into your server, and you can now go ahead and access that information with the commands, with prompts. And the value that you're going to be able to get out of accessing this like oil well that's sitting beneath your feet, I think is going to be very powerful. Even using a GPT or something like that, you can get to a lot of it very easily. Very nice. And then the last thing that I've noticed in my career that I think is going to help is, as a younger engineer, I would rely on my structural design software too much. Why did I do that? Because when I was coming out of college, I didn't truly understand first principles, what needed to be designed and how properly they needed to be designed. And I was lucky when I was an intern, I was just making models of everything. And I would go to my management and I'd say, here's the design for the shear wall, let's say. And they would ask me, well, why is there no bundling in the corners? How are you distributing load throughout the wall properly around the openings? I didn't really have a great answer, but everything on my screen was green and it looked good to me, and I ran with it. And why did you do that, Dan? Because I didn't know. So now, with large language models, I think it's going to be a great educator. So when you have people that are just using these softwares blindly and you don't really understand necessarily all the intricacies and details of what's happening within your design process, you have someone to go and ask questions to that isn't necessarily your senior engineer or your principal engineer, because they don't have the time to sit down with you and hold your hands through every question and every problem. So I think that AI can also be used as a great educator for this young generation of engineers that's coming up now. So for the firms that are looking to explore an AI strategy and they come to me and they say, hey, Dan, what should we do? The first question that I pose is, what is your AI strategy? What does that mean? What does that entail? What are we talking about here? So first, we should define the scope of AI. What is AI going to be doing on our projects and in our workflows within our company? Two, what kind of model architecture are we going to use to make this a reality? Three, how is risk going to be assessed and delegated with using this AI? Four, how affordable is it? How accessible is the information? As a business owner, you always want to know, what is this going to cost me? I think it's a very important conversation to have, and we're going to have it here today. And five, what is happening to my data? This data that's so valuable, that's so important, it's proprietary, you're making it, it's all yours. What happens to that when I go and give it to a large language model? So we'll talk about this in detail. So AI scope of work. And as I go through these, you're going to realize that this process is iterative. I listed off 5 major bullet points of things to consider, but it's not going to be as easy as just checking off boxes as going through this. It's going to be a very iterative process. So what I mean by that is, first off, what are we going to use the AI for? Well, it depends on what the AI can do. Is it really good at calculating and putting together calculations and doing structural design? I don't know. We have to figure out which types of language models are good at certain tasks. Is it really good at prompting for email generation and polishing up of reports and generating reports? Well, as a firm and as engineers, the way that I've seen it develop is companies or engineering teams will run beta tests for a few months, and they'll delegate, hey, we want to use AI to generate reports, check calculations, and help us answer some basic submittal reviews. And they'll do a beta test for that for a few months, and they'll see the accuracy that they're getting back. They're figuring out if their quality of product is increasing. They'll figure out if they're saving more time and they're more productive from an engineering perspective. And with that, they're able to kind of calculate, hey, this is what we're going to want our strategy to do and what we don't want it to do. Putting up guardrails for AI, because I was talking to a firm out in California a couple months ago, and the principal came, he reached out to me, and he said, hey, Dan, I have a young engineer, and we were walking through a design review with him. And he responded to us that he was getting a lot of his information for his design from ChatGPT. And what do we do about that? Well, I asked him, like, what is your AI strategy? Do you allow for engineers to do that? And he said, we don't have an AI strategy. So we helped that firm create an AI strategy to put up these guardrails and saying, hey, when you're using your AI, you're properly using it for these tasks, and other tasks are improper. Do not use it for that. Giving your engineers structure. And like all emerging technologies, the younger generation is going to use them. So you could put your head in the sand and say, well, we don't want to think about it. If they're going to use it, we don't want to know, and that's the risk that you're going to take on as a company. But as more and more people graduate and they come into your teams and work with your companies, you're going to have to sort of addressing this problem of, hey, how are people going to use this technology? And the second part of the scope is, hey, what does your company need? If you're really bottlenecked from a submittal review standpoint, maybe that's somewhere you want to start and say, hey, can we really build out some great tools to help us streamline and make our workflows for submittal reviews more efficient, a higher quality, make your engineers more productive, things of that nature. So model architecture, what does this mean? This is the actual software applications that you're going to be installing and deploying to achieve your AI goals that you're defining in your scope. So the foundation, these are your large language model foundation models. These are like the GPT-4os, the Gemini models of the world, the Llama models of the world. These are all these large Silicon Valley tech companies that have created their own base models. They've actually taken large sums of data that they've probably scraped from wherever they could find it on the internet, and they've made these large generative models. So when you have a very generative model, it's generalized, meaning that it's not tailored in a specific way or for a specific use case. And that's where you get a lot of hallucinations, a lot of misinformation. And for us as civil engineers, it's not very valuable. It's not very useful when this thing is lying to us, when it's not giving us the proper information that we need. So how can we make that better? There's a term called agentic middleware, and that sounds kind of alien, I know. All that is you're building more software on top of the language model to get it to perform a very specific goal. So if you want the language model to remember the conversation you're having with it, you could build in an agentic middleware called RAG, and that's retrieval augmented generation, meaning that it's remembering the conversation that you're having. So that way, every time you enter in a new prompt, it's like you're having a conversation with this thing. It's not a new prompt every time, a new conversation every time. You could also do something called multimodal reasoning. What is that? Multimodal meaning multiple types of input. So instead of just having it be text input, you can go ahead and scan drawings, throw it into a model, see what it returns to you. You can go ahead and take pictures out in the fields, throw that into a model, see what it brings back to you. And you can work with these different types of data sources that we're using. And as civil engineers, we see a wide variety of these data sources. And it's very advantageous for us to have a program that works with multiple types depending on what you want to do with all this information. And the last one are module tools. They're also known as agents. Is anyone here familiar with the term agents? Have you heard of that before? Yeah. So what an agent is, it's a program that was given a specific piece of data and a very specific task, and it completes that through and through. There's no human intervention in between. So very simplified example of this would be you give GPT a command saying, hey, can you give me the capital of all the 50 states? It'll go ahead and it'll process that for you. People that use like the scheduling tool on GPT as well, that's a really good one where you say, hey, every day at 3 o'clock every day at 3 o'clock, let's say, remind me to feed my cat. And every day at 3 o'clock, it'll send you an email and it'll say, hey, go feed your cat. So that's what an agent does. You're giving it a very specific task and it'll complete that every time is the goal of the agent. So as civil engineers, what kind of agents are we going to build? Do we want to build agents that are going to perform or, let's say, generate inspection reports for us? So you're going to go to the field, take pictures, give brief descriptions, and you give it to an agent and generates a report for you. That might be valuable to you. Or for concrete mix design reports, do you want to be able to give it the concrete mix design, your data, and then a standard operating procedure of how to review the two? And then from there, you'll get a report and that submittal review outcome. So again, it's all about what we want the AI to do. And again, very iterative process of trying to figure out what exactly all this is. So something that's very important to us is who's liable for all of this. So let's say your AI program spit out something and it was incorrect and it got built that way, and then you get sued or there's a change order. What happens? I don't think it's properly defined right now through ASCE, and I'm working with the AI task force for AICE to help try to define what these guidelines and what these risk parameters are going to look like. But in my personal opinion, I view it very much like a design software. And the design software is great, but whatever it gives to you and you sign off on and you use, the ultimate risk and liability is on you, the engineer. So what do we need to be? Yes? I mean, even right now, let's say software like AutoCAD. Mm-hmm. Mm-hmm. If it gives you a wrong result, at the end, I don't think software liable for that, or the engineer who problems. It's the engineer. It's not the company. I'm assuming it's going to be the same thing. Exactly. The AI will be the same. I view it in that way. Yes. I don't think that you're going to go and sue your AI provider for mistakes that you've made on your drawings and your projects. Make sense? Yeah. That's the same thing. Like AI, for example, give you a summary of action items for meeting minutes or something. Mm-hmm. Exactly. So for us as engineers, we take on a lot of risk in everything that we do. And you have to trust the systems that you're working with. So for me, I always advocate for people understanding what the program is outputting and how it's outputting it. So if you're doing a very specific submittal review, you should understand how it made all the logical checks that it made. And is your AI provider providing verification for that? Are they being transparent? Are they telling you how they got this answer, or are they just giving you an answer? I think it's a conversation that you should have as a firm. And the last one is false confidence. So I was talking about hallucinations before. Hallucinations are the term when AI lies, when it makes up a piece of information and it's just not true. And it looks really right and it sounds really good, but it's just wrong. As I've learned, it's not the software's fault. It's just there's constraints and parameter limitations around it. But as the engineer, we need to know when is it correct and when is it incorrect. I think it's very valuable to know. So accessibility and affordability. I see it, there's two ways right now how firms are deploying AI. One is in-house, so you'll have your own model that you're creating in-house, hosting, maintaining, and using. And then there's a third-party provider. So there are companies like mine, Ferris, we're providing a third-party option as well, but there are other companies that are providing AI solutions for you, and what do the costs for that look like? So the first line item here, I don't think anyone in this room or anyone in our industry is going to create their own large language model from scratch. That's a multi-million-dollar endeavor to do. But if you wanted to, and you have the capital for it, maybe it's for you. I don't know. But typically, I don't see a lot of companies that are trying to make their own language model. Second part is fine-tuning. What is fine-tuning? So you could actually take these base large language models and you could add different parameters to them. You could change their weights. You could embed specific pieces of information and data on them to have them more fine-tuned to your company and what you're trying to achieve and what goals you have. This, depending on how you want to fine-tune it, can vary in costs, but from what I've seen, it's a very expensive endeavor. And that's because in our fields, we need so much data to start making actual meaningful inferences based off the drawings that we have and the submittals that we get, the calculations that we get, because there's such a variety of data that we get. Every company has a different standard for their drawings, calculations, submittals. Every project is different. Every owner is different. And all of this, I call it democratization of ownership on all these projects, but that leads to a great deal of data variety, which in turn is higher costs when trying to fine tune these sets. Something that I like to talk about too, if you're thinking about fine tuning, and for me as a third-party provider, this is probably against my personal interest, but it's the truth, so I should say it, right? The results you get from fine-tuning are very good, I believe. I've seen it work firsthand, and I think that you get really good results when you're fine-tuning, but it's just that cost that really scares people. So if you're new to AI and you don't really see the value in it yet, then maybe fine-tuning is not for you. But I've seen firms that kind of believe really hard in this kind of stuff, and they fine-tuned, and I've seen some really impressive stuff that people are working on out there. So keep that in mind. Infrastructure and hosting. If you're going to host your own language model, again, you need the server space for it. If you need GPUs to fine-tune it and train it on, that's all going to be a capital cost as well. On top of that, you need an engineering team and a compliance team that's going to do that. Again, who's going to make this language model for you? How are you going to host it? How are you going to keep it up to date? Every time you create more data, you need to go ahead and put that into your language model. So that's another cost that's going to be recurring over time. So all things to think about. For me, when I'm looking at it, for the first year, you'll probably run somewhere like $1 to $8 million if you want to go ahead and just fine-tune your own language model and have it running on your own servers and own systems. And then over time, depending on how much data you keep feeding it, it'll cost maybe $400,000 to $2.5 million per year. So on the other hand, you could go to a third-party provider where your cost for making a language model is nothing. The fine-tuning portion of it, typically how I'm seeing third-party providers fine-tune language models is you give them your data and they have a system in place that will embed that information onto the language model for you. So you're not responsible for picking out a GPU, figuring out different ways to change your parameters and change your weights within your language model. The company will take care of that for you. You just have to give them the data, and there's typically a cost that's incurred when you have to give them your data because it costs them money to embed onto a language model. But typically they have a process and a procedure which is more efficient and more cost structured to make that investment a little bit more palpable for the engineering firm. Infrastructure and hosting, third-party provider takes care of that for you, so you don't have to worry about how this is going to get hosted or the actual software infrastructure. That's part of the deal. Engineering and DevOps, you might have to invest in a small team at first to figure out exactly how you're going to be utilizing AI. I call them like beta teams or champion teams within organizations where you'll set up a team of 3 or 4 depending on the size of your organization. You'll give them a software and you'll say, hey, here are our goals. Experiment with this on our projects and see the results that you get. So there might be an immediate cost for that when you're trying to figure out, okay, this engineer, 5 of his billable hours a week are going to be going towards us experimenting and figuring out, hey, how AI is going to help us. And then you might also have a compliance team as well, trying to figure out, okay, how are we going to deal with this risk? How are we going to deal with actually navigating the waters of delegating judgment while using AI? In my opinion, using a third-party provider is much cheaper. It's what I've seen since I've been doing this, extremely cheaper, orders of magnitude cheaper, but you don't get as much control or freedom over the system. So you kind of have to weigh the two. And then data security. So what is happening to your data? Where is it going when you put it on a language model? If you are hosting everything in-house and you're doing everything within your own servers, you kind of know where your data is going and staying with you, which is advantageous to a lot of firms, and a lot of firms like that. It comes at a cost. It's not free, but there's an advantage to that. When you're looking at third-party providers, the one thing I would say to look for is figure out whether they're like industry standard compliant. So there's an ISO 27001 standard, which is very industry standard, and there's also a SOC 2 compliance. And this is making sure that when your data is within some sort of hosting system, the data is being encrypted, how the data is exiting and entering those systems are controlled and monitored and verified. These are industry standards that not only software providers use, but banks use them, Healthcare industry uses them. Accountants use them. This is an industry-wide standard that I think if you're looking at a third-party provider, make sure that they have some sort of standards and credibility so that you're not just handing over your data. So if you were to use like a DeepSeek model that came from a Chinese lab, what happens to that data? Who sees that data? What are the odds that you'd bet that the CCP doesn't see your data? I probably wouldn't take that bet. So things to think of is what's happening to your data, where's it going? And then the last thing is accessibility and control. So if I'm handing my data over to a third-party provider, are they taking that? Are they using it? Are they training models off of it? Do other people within their organization or some of their clients, do they have access to that information? I think that's something that you should ask your third-party provider and have an understanding of it when you're using the software. So meet Ferris. This is the AI third-party providing company that I've started. And while we offer a software platform, we also do consulting. We also offer engineering services. And we have our AI platform that we are building every day and we offer to our clients. So I would like to kind of take some time to talk a little bit about what we're providing and what we've built here. So the Ferris difference. So why don't just use ChatGPT or Perplexity or Claude? Well, when I was an engineer, I was using those softwares and they weren't giving me the results that I wanted. Obviously, they would lie a lot, but then also sort of the tools that were within them, they weren't built for civil engineers. And I saw so many tools that we could build that I think we'd have a lot of value in. So I went on an endeavor and I started to build it myself. So when you're looking at Ferris, what makes us different? One of the things is the context window. And I'm going to go into great detail on this. It's going to be a little technical, but I'm going to try to not get too lost in the weeds. But it's very important from a hallucination standpoint. Our hybrid architecture, kind of how we're doing it from a software side. Our civil engineering tailored agents. So we are actively building civil engineering agents every day. And we have one client, and that is a civil engineer. We don't serve any other markets. We don't serve any other teams. And that's something that I can say a lot of these other AI providers cannot say because they service many markets, many teams, many different types of industry. And I don't think civil engineering is at the top of their minds when they're developing their products. But here at Ferris, it is the top of our mind. It's our number one priority. Accessibility and affordability. We'll talk about what we offer kind of like cost-wise right now. For a single seat, it's $60 a month. But we work with firms from a services perspective, a consulting perspective, and then also from a platform perspective where we work out specific deals based off of the firm and the number of seats that they need. But I like to say that it's $60 a month if you were just one engineer trying to use it for the first time yourself. And then data privacy and protection. So we are SOC 2 compliant. The highest priority that we have from data management perspective is that your data is safe. And the only engineer that sees your data is you interfacing with Ferris. No other engineer that uses the platform has access to your data. We do not take your data. We do not train language models off of it. When you pull your data off of Ferris, it is gone forever. It's never staying within our servers, within our systems. And we really believe that that data is proprietary. It's yours, and you should be able to have control over where it goes. And we don't own that, so we don't take that. Yes? If you have that separation, how do you, part of the strength of AI is being able to access all kinds of experiential data to give you the best results. So if you separate each user's data, you don't get that advantage. That's a really good point. And when we were developing it, we ran into that almost immediately. And what we've worked with firms on right now is having a lessons learned piece of documentation that every engineer has built within their systems, and that gets updated as more lessons learned are incorporated. It is a friction point, and it's something that we're trying to work to, and it's a really good point. It's not perfect. We don't have the collaborative feature at the moment where multiple accounts can work on the same projects, and it's something that we're working to and trying to build, but there's that data security portion of it that we're trying to balance. But the best way that we've learned to mitigate that is when you have this experience, that's why I said write it down. I know engineers that really love using what we offer. They have their own experience logs, and they use that within Ferris, and they have that experience, and that experience is withheld only within their model at the moment, but hopefully here in the future we can build out something where it's within a team environment. So great question. Thank you. Did that answer your question, by the way? I didn't want to just move on. Yeah, cool. So context window, what is it? Why is it important? So when I found out that AI was lying, I asked myself why. One of the reasons why it lies is because of the context window. What a context window is in a large language model is the number of characters and words called tokens, but we'll call them words for now, that you could look at one time. So if you're looking at any sort of commercially available model, like a GPT, a Grok, a Claude, they process 128,000 tokens at a time, which is 100,000 words, which is about 300 pages of a PDF. So as civil engineers, we process many more words at a time than just 100,000. If you just look at our building codes alone, never mind our drawings and all of our calculations and all of our specs, it's just a massive amount of data. And here at Ferris, we've been working full time now for 3 months, and we've already processed 3.5 billion tokens. So it's like 3 billion words right now that we process. So it's just so much data that we're getting. And why it's important to have a large language model that we have here at Ferris, where we're able to process tens of millions of tokens at a time as opposed to a small one, is that when you're querying through and you're trying to command the AI through large data sets, if you have a small context window, it only looks for the information to provide to you within a very small bandwidth, and it's not taking the full amount of data that you're giving it to make a decision. With a large context window, it's taking into account all of the data that you've given it, and it's going to make a decision for you based on all the data as opposed to just a small portion of it. And that's what happens when you get hallucinations. You ask a question or provide a command outside of that context window, and it fills in a response that's not data-driven. It's hallucinated. So does that make sense? Hope so. Thank you. Okay. So our core features right now, we're really trying to work from the data and document side at the moment. So we're very PDF and Excel compatible. We like to be able to take all your building codes that you adhere to, all of your company specifications, your project specifications, drawings, calculations, have them embedded within a language model. So now you could go ahead and I'll show you my demo in a little bit, but semantically search against them, use them in submittal reviews, check calculations with them. I think these are all great features. And one thing that we really stress when we're building our tools and we're building our agents is verifiability. The AI is going to give you an answer. How do you know that it's right? You have to have some sort of way to verify that. And we build within our platform ways to verify it with our side-by-side comparison feature. And we're trying to produce different confidence indexes so that you can get a better understanding as, hey, is this thing accurate or is it lying to you? Good question? Yeah. 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 Yep. Some of our companies have to, and if that's a disclaimer that they're putting there, that's something that you probably should adhere to. I know they're trying. Yeah. Mm-hmm. Yeah. Yeah. I get that. I mean, there's a very big conversation that's going on right now, and is code law? So can you put code and legally hold people responsible to it, but make them pay for it and then not have them have access to it? So the example that I like to use is, let's say the Department of Transportation, they put out speed limits, traffic law, and you could all view it. That's great. But what if Google Maps or Apple Maps couldn't access that data and they couldn't make technology on top of it? Think about the technological burden that would have on us as a society. So there's that similar argument going out right now. So there are code issuing firms that are taking that stance and they're saying you can't use it in large language models, and that's unfortunate. But we offer things outside of just code querying. That's just one of the features that we offer. So our data sources are all user provided. So whatever your data is. That's what I'm saying though. Like my ASCE would be my data. Well, then if they're telling you that they can't put it onto a language model, then that's what they're telling you. That's on the engineer. Mm-hmm. Mm-hmm. So anything that's internet wide that you could scrape off of the internet is typically within a large language model. For engineering purposes and for accuracy purposes, I always say if you're using a document and you want to have that data within your model for sure, and you want it to be the correct version of it, because there are different versions of all these types of codes and all this information out there that you could have within a large language model that's not up to date. I always say put your own data onto the language model to ensure the quality of it, the consistency of it, and that it's exactly what you want and what you're looking for. How these large language models were constructed was just scraping large amounts of data off the internet, and it picks up really good information sometimes and really bad information sometimes. And I think it's on us right now to curate, curate that data source. So we're saying, hey, this is the data that we want to use, and you put that within Ferris in this example, and then it'll use that as a reference, and then our agentic ecosystem will work over that data that you provided. Does that make sense? Yeah. Yep. So we don't delete or enter any data. So if, let's say, you wanted to look at ASCE 716 and compare it to 22, we have a feature within Ferris where you could take two PDFs and compare the two and list out the differences. That's something that you could do. If you're trying to figure out what has changed in the code, we have tools that help you figure out what has changed if they're not explicit or you can't figure it out. But if you're using an outdated data source, we're not going to change or manipulate that data source to make it up to date. Does that make sense? You could ask it that, and maybe it'll give you the correct answer or not. That's it. I've never heard that question. That's a really good question. Yes. That's great. Yeah, that's perfect. Mm-hmm. 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 Yeah, those are the types of features that we're working on. Yep, you're perfect. Yeah, there are compliance checks within there where they'll tell you. Yeah, exactly. Yes, so you would have to prompt it to ask it to do that check. So hey, make sure this is compliant versus this standard that you enter. Yes, that's what we would allow you to do that here. It's not an automatic thing at the moment. It's something that you'd have to prompt it and instruct it to do, saying, hey, take a look at this report that I generated, make sure that my procedures and standards are in accordance to ASTM, even though we can't use their code right now. But something like that. Yes. Well, we care about copyright laws at Ferris. That's why we don't take any of that data. Mm-hmm. So that's kind of the conversation that I was talking about before. Like, is code law? And if code is law, which legally in court it's been defined as law in the Upcodes versus the Southern District of New York case of 2023, I believe they finished that case, where they said that code is law. So you have to have it be accessible to engineers. Yes, they have to adopt codes, and they hold you legally responsible to those codes. So it is the law for us. And what that court case set the precedent for, along with public resources versus the state of Georgia in 2020, which went to the Supreme Court, that all these codes cannot be hidden behind paywalls. So what the ICC did was they set up on their website a nice viewable platform where you can go and you can view all this information. So you have access to it. It's no longer behind a paywall. What was that? You can't download it. You can't access it. You can just view it. So that's the conversation that I'm trying to have today is, if we really have access to that, shouldn't I be able to download it? So there are actual like firewalls and things put in place on their website where it blocks large language models from getting in there and taking that data. So yeah. And also, depending on the large language model that you're using, you have access to different data sources. So let's say you're using Grok, which is owned by Elon Musk, and he also owns Twitter. So you get access to all that Twitter information. But GPT is not allowed within the X ecosystem. So it can't take that Twitter data and provide that to you within its GPT format. It's the same thing for those users that use GPT pretty often. If you've recently tried to take a screenshot and upload it to GPT, it actually fails because the way that Apple saves their images as an HEIC file is no longer compatible with ChatGPT because Apple's like, we don't want you to take all of our screenshots that we're producing. That's valuable data to us. So there's like this data war that's happening in real time right now where people are trying to figure out who owns this stuff, who gets to use it, and how are we going to kind of make our way through this into the future. So it's a very open-ended question. That's a great conversation. Thank you very much. Okay, so how are we helping engineers with their problems right now? From a data complexity standpoint, we're helping engineers get access to information quicker. So when I was working as a civil engineer, kind of how Ferris started was architects would come to me or the MEP team would come to me and say, hey, we've got a clash here. Can we reduce the depth of this beam to reduce the clash? Okay, so me as an engineer, I'm in a meeting, I take note of what beam we're looking at, I go back to my desk and got to find it in the drawings, got to find it in the calculations. Then by the time I actually get to the calculations, it might be 15, 20, 30 minutes, depending on the depth and the breadth of the work that you're doing. On the Mobile Watch 2 project, we had thousands of drawings that we issued. We had thousands of pages of calculations that you issued. And all these calculations were segmented into 132 calculation packages by the time I left. So it was very difficult sometimes to find where we're qualifying this beam. So it would take engineers a long time to figure out what the information is that they should be even designing to. So at Ferris, what we're able to do is you can now put all this information within a language model, and you could ask it, hey, where is the calculation for this beam? And then you can go there, and then from there, we have private tools for generative calculation design, but we don't get into that right now. We kind of just keep that within testing just because we don't think it's ready for commercial use at the moment. But I think it's very good at getting you from the point of curating data and having data be at your fingertips. And when you're looking at it from a decision fatigue perspective and a bandwidth perspective, how much of your time and energy is used just trying to curate information and get it to where you need it to be to make that engineering call and decision? That's something that I thought was a really big problem. And I think with Ferris, we're helping a lot of engineers kind of overcome that issue. So siloed knowledge, this is kind of what we were talking about before. You have all this great data that you've produced over so many years at your firm. And let's say you're working on a project and it kind of reminds you of a project that you did 5 years ago. How do you reference that project? You typically fumble through your file server and try to pull it up and figure out, is this detail applicable? Is this not? I've done it so many times, and every time I was doing it, I'm like, there has to be a better way. So now with some sort of a language model that we provide here at Ferris, you can go ahead and semantically search like a catalog of details that you have and get to the exact one that you need and see if it's applicable to the condition that you're working on. And the last one is redundant reviews. I call them redundant, but they're not really redundant. I was talking to my old boss when I was telling about Ferris, and he goes, Dan, you want to automate all these submittal reviews, but that's how our young engineers learn. And I thought about it, and he was right. That's how I learned. I learned off of steel shops, and I learned off of concrete submittal reviews and product data sheets, and the work's not glamorous, but it's how I learned. So something that we are working with now in Ferris is you could automate these tasks, which is great. So we create what we call a recipe. It's a standard operating procedure for your company. So let's say for your concrete mix design reports, you're checking aggregate size, you're checking water to cement ratios, your admixtures, any sort of logic check within a submittal review, your company can now standardize. So as opposed to me as a young engineer saying, how do I check this? I ask an engineer, I get one answer. I ask another engineer, I get another answer. Your company has sat down, you've thought this workflow through, and now you have a very specific way to check these submittal reviews, which is increasing the quality of products that we see across the teams that we get to work with. So that's something that I'm very excited about. And then not just automating it, but within those logic checks, you could explain to your engineers, hey, why are you making these logic checks? Why does the water to cement ratio matter? Why does the aggregate size matter? So it's not just them blindly clicking buttons, but you're actually educating them, because I think that's the more important thing here. As someone that works heavily in AI, and I think it gets kind of a bad rap that we're just going to like offset all of our thinking to this tool and this technology, and that's not where I stand. I think that as humans, we have a very creative portion of our brain that we use to reason and judge that us as civil engineers we use every day, and I don't want my generation to just like offload that, because there are going to come times where your problems are not within known data sets and known parameters, and then what do you do? I want my generation to have the answer for what to do, or at least have the cognitive ability to figure out what to do. So that's what we're trying to do here at Ferris. We're not trying to just be this blind plug and chug software. We're trying to allow engineers to think through problems and become better engineers by increasing their bandwidth. That's really our goal. So just some ending notes. I know I talked for a while, but Ferris, we want to champion the civil engineer. Like I was saying before, all these AI providers right now, they provide for the broad market, the general market, and they're not really making tools for us. And I think that we should have our own specially made tools, because what we do is incredibly specific, incredibly detail oriented. And unless you're an engineer, I don't think you really understand it. And the tools that you make are not going to be exactly what you need. So here we're trying to make tools that are specifically tailored to you, the civil engineer. And then at Ferris, our foundation is trust. If that's the one thing that I have had a magic wand, the one thing I would do is I would say every time an engineer sat down and they used Ferris, they would trust our software. So how do we build trust? We build it through verification, we build it through transparency, and we build it through honesty, being honest about what we know, what we don't know, and then trying to build that relationship with you, the engineer, saying, hey, I go to Ferris, it answers 50% of what I have, and the other 50% it tells me that it doesn't know, and I can live with that. At least it saved me 50% of the work. I'm not going to sit here and promise you that it's going to solve all your problems, because it's not, and I don't think AI is, at least not in its current form. Something that people like to say a lot is that AI is going to replace us and replace our jobs and everything that we do. I don't see it that way currently. I work with it every day, and I just don't think the reasoning capabilities are there to make those human level decisions and judgment calls. But what I think it's really great at is taking your expertise and your judgment and scaling them. So what does that mean? Going back to the concrete submittal review, you have that standard operating procedure, you have your experience, you have your judgment, you have your logic that you've developed and crafted over many years. Now you can apply that over 100 submittal reviews at the click of a button. And that's where I see the value. It's taking what you know, your experience, and your expertise as engineers, and applying that at scale. So I think that's going to be very powerful here with AI.
You say automate, basically, I have to build the software. This is.
I would love to show you it if we have time. Jamie, what time is it? Do we have time for a demo? Or am I running out of time? Oh, okay, cool. Yeah, can I show you some examples? Is that a good way to start? Okay, cool. So this is our platform here, Ferris. We try to structure it. Can you see it well? Sorry if you can't. Okay, cool. Thank you. So I try to structure it the best way that I can, and I wanted to structure it based off of something like how we work as civil engineers. So we have like our projects that we set up on a daily basis. So within those projects, I typically put project-specific data within them. And we also have a global documents library. So these are all the codes, company standards, other types of documentation that are not project-specific, but are applied broadly. And this is just from a data structuring perspective, so you have an understanding of where things are. So when you're using the software, you know how to use it more effectively. So let's say I am let's say I want to find a specific detail within this drawing set. So this drawing set here is scanned, meaning that there's no metadata in the backgrounds. And when you go to do Control F, let's say we wanted to look up concrete, nothing comes up. Have you ever experienced a PDF like that before, where it's scanned, nothing comes up, there's no metadata in the backgrounds? So that was something that I saw as a civil engineer. I'm like, this is not advantageous. So at Ferris, we use two types of data extraction. One is the metadata, another is a visual extraction of data. So I got some pre-made prompts here. So I'm going to ask it a question for time's sake. And I'm looking for, let's say, locate the open terrace detail. And within this drawing set, there's 93 pages right now. And when you're trying to just thumb through 93 pages and find the right detail, it takes a lot of time. And it's really annoying. So hopefully with Ferris, we're able to get where that location of that detail is. So it's telling us this one is on page number 6 and it's detail number 10. So we'll open up that side-by-side comparison tool that I was talking about before, because I don't want you to just trust it. I want you to see it. And this is that detail open at terrace. And just to show you the context window, because when you're looking at drawings, the token number ramps up to above that token window very rapidly. So I want to pull something maybe in the back of the set just to kind of show you that we look at the whole drawing set itself. So we'll look for a knee brace detail. And let's see, it's on page 93 of this drawing set. And then it's going to give us some information on what's going on there. And yeah, that's just to prove that it's scanned. Also, there's a sticky note on there of what the detail is. And then this is that knee brace at the pergola detail within that drawing set. So just a very quick example of kind of how you can get around and navigate your data sets and your drawings with it. Let's see another example. You wanted to look at the concrete submittal review one. Let's take a look at that. So within Ferris, we've got 3 agents. I'm doing a really bad job of explaining this right now because I'm rushed, but we've got the deep query agent, which is really good at going ahead and looking through large data sets for you and finding pieces of information. That's where our verification link tool is currently only available, which we're working on having it available in our other tools, but that's where you can verify that information very quickly. We have the verify calc tool, which will go ahead when you put a calculation in, it'll check your math, make sure you didn't fat finger any numbers, make you a little bit more confident in your calculations. And then we have our submittal review tool. So you can go ahead, enter a single document, and then enter a recipe or a task that you want it to do against that one document, or you can enter 2 documents and have a comparison of those 2 document sets. So here we'll do the 2 document sets, and what I'll take into account. Oh, I thought we were capped, but also I don't want to take up everyone's time all night. It's Thursday, people have to go home. Sorry. I'm sorry. I'm talking like an auction person right now, just blabbling. Okay, so we're going to take our concrete mix design report, and we're going to take the drawing set that we want to check it against. And for simplicity's sake here, we're just going to look for that 28-day compressive strength. So we're going to go ahead, we're going to enter that. And this is that concrete data report. Let's see if this loads while it runs in a minute. So we should be looking for here the compressive strength of 6,000 psi. And then this is the drawing set that we're looking at. And the minimum compressive strength here is 4,000 psi. So if we go back to Ferris, it's pulled out that information. So document 1 is that concrete mix design report at 6,000 psi. The document 2 is your drawing saying 4,000 psi, and then it's telling you, hey, it meets the minimum concrete design. It's a very simple, simplistic example just for time's sake. I don't want to explain every logic check that we do, but at its core, that's what you're going to have it do is create a recipe for what data you get in, the data source you're checking it against, and then the logic checks that you do in between to get from A to B. That make sense? What's up?
That actually have to be populated on the Ferris app, or can you just run the server so you don't have to populate everything?
It has to be populated on our app currently. Yeah, that's how. So you might ask yourself, how did we overcome this large context window? It's not that I'm a genius or anything like that. It's the software applications out there are available, but it's expensive. It's more compute. And for these larger companies, 99.9% of their market is not needing a large context window. We're in a very small niche industry where we need a large context window. So these companies can offer that, but it comes at a great expense to them. And for their core clientele, they don't need that. But us as civil engineers, we need that. So I felt like we should build something that had that large context window in there. And in order to access that large context window, you need to upload your data to our system. Does that make sense? What examples do I got here? So I have an example where you could take some like building department questions or RFIs, and we can answer them in Ferris. So I've got, check the right project. We're in the Navinta project. And we're going to do Navinta structural questions versus the Navinta structural. And we're going to say, so we want to answer the questions, yes. Something that I'm playing around with and my team is playing around with is adding confidence scores. So you're going to see that live here. So if it bombs and explodes, you can all laugh about it. But it's been operating pretty good right now. And we're asking it to give it a confidence index on its answer. So 1 being 0 confidence, I don't know what's happening, to 10 being perfect confidence, I know exactly where this is coming from, just so that you kind of know when it's hallucinating and when it's not. So we're going to go ahead and we're going to run this. And do I have those questions? So these are the 5 questions that I want to ask it. So 1, what is the design wind speed being used? 2, what is the concrete strength specified? 3, what are the weld inspection requirements in the general notes? 4, what is the tension development length at a haunch slab detail? And 5, what is the rebar opening in a CMU lintel for a 10-foot wide opening? So let's see what Ferris has populated here. So, and we'll check each one of these to see where it's right and where it's wrong. So it is 170 miles per hour. That's the answer question 1, which is giving us a confidence score of 10, 4,000 psi for the concrete, which is confidence score of 10, which we saw before, so I think we can verify that. We'll verify the wind speed here. So basic wind speed is 170. Can you all see that well? Okay, cool. So we have the first 2 questions answered correctly. Then we're going to go down to the weld inspection requirements. So it's telling us that weld inspection requirements include 100% visual inspection of all welds, spot testing of fillet welds, partial penetration welds using magnetic particle testing, and 100% ultrasonic testing of full penetration welds. It's not the best response. I don't know if it provides much value, but it comes from a place here. So it's where it's saying, oh, well, it's visual. So it's providing that piece of information to you. It's giving the spot test with the mag particle. It's giving the penetration well testing. It does cut off a little bit of the bottom though, so it's not perfect. I will say that. And then moving to number 4. What was that? Yeah, but it could be better. We want to make it better. I think it's important being honest with these things. When they're not right, I shouldn't lie about it. I should be telling you that it's not right, and then I should go back to my desk and fix it. So that's what we're going to do here today. The tension development length for number 4 rebar at the haunch slab, confidence score of 9, giving me wall 12 inches. This is not the response that I wanted, and this is incorrect. So when you're looking at, all the structurals know, when you're trying to figure out what that tension development length is, it's kind of an arduous process. You go to your detail, so this is the haunch slab, and you're looking for that tension development length. It's not specified. You need to know the rebar size, so you hop down to another detail. It's the number 5 rebar. And then from there, you go to your tension development schedule, and you have all these other variables that you need to define. And if these aren't technically fully explained, Ferris does a really bad job of trying to figure out what the variables should be. And I think all AI does a really bad job of trying to figure out what the variables should be. So in these cases, we typically see hallucinations and wrong answers there. And I was hoping that it would tell me that it was a wrong answer, but it did not. And the last one is for a CMU opening of 10 foot. When you're answering, looking for 2 number 6s, this is actually what I wanted. And where does that populate in our drawing set? It's here. So for openings, 6'1" to 12 foot long, it is 2 number 6s, and then that's what Ferris is populating. So again, something that we're trying to get better at is telling you when we're wrong. I think it's incredibly important. Didn't do a great job here, and I'm sorry about that, but that's life. We're working, we're building. We've been up and running for 3 months now, and it's been a very exciting 3 months, and it's a baby in its current form, but we're here to not just offer a software platform. We're here to guide you through what practicing in AI is going to be in the future from a consulting perspective, and then also, like I was saying before, working with the ASCE to provide a task force, to provide guidelines, to provide clarity in a lot of this chaos. So that's kind of what I have today. Are there any more questions or concerns? Question?
Now, this app, for example, is installed in personal computing. Cloud data, so like basically they can share the history.
No, so right now it's a web-based app. So you go to askferris.io, and I'll share my my LinkedIn. I have some QR codes if you want to follow us on LinkedIn. You can go to our website, askferris.io as well, where you can find more about what we're building, and I try to do daily updates. I try to build in public as best as I can, so whenever we come up with a new feature or we enhance our products, I'll be posting about it online to let everyone know what we're working on and what we're doing. But per the question that we had before, right now there's no data transfer between individuals. It's very much siloed off to your account, your information.
But it keeps, for example, history algorithm to example, if you ask the question the first time, and the next time you ask the question, maybe if you ask a little bit, have history. So have like
At this moment in time, we do not have history. It's something we're launching this summer. Is within the Deep Query agent, we'll actually be keeping a history of your conversations and a log of what you're working on. Yes, that's something we need that we'll be developing, but we don't have currently. Any questions? Anyone else? You guys were great. Thank you all for your questions. I really appreciate you guys taking the time and having a conversation. Thank you. And thank you, Jamie and the board, for having me tonight. I really appreciate it. Thank you all. I hope everyone learned a little bit of something. I know it's a lot to talk about in an hour, but yeah, we're going to keep trying to have the conversation because there's a lot of conversations that we need to have around this kind of stuff to work with it properly. Thank you very much. I appreciate it, man. You too, man. Thank you. Thank you very much. I appreciate it.
Thank you.
Very nice to meet you. Thank you. I appreciate it. Hope you learned something. Very nice to meet you. Thank you. Thank you very much. It was very nice to meet you.
thank you.
Thank you. Thank you, man. Appreciate it.
Thank you. Very informative.
I hope so. I hope so. Thank you very much. I appreciate all the questions. They were very good. Very good questions. Thank you.